I'm going to talk about stage 1, that is called fluids. First of all, we're going to start with states of matter. There are solids, liquids, and gas. Solids have defined shape and their intermolecular forces are strong. Liquids are capable to flow, and their intermolecular forces are weaker than the solid ones, and their distances between the molecules is larger than solids. In gases, they compress easily and take all the space in the container. They also have a great distance between molecules. Here we have an example, an ice cube, a glass of water, and a cloud. And these are the arrangement of the molecules of solid, liquid, and gas. Now, density. Here, as you can see, is the formula that is mass over volume. Density is a scalar quantity in the International System of Units. Their units are kilograms over cubic meter. It is unique for each material, as you can see here. This is for honey, sugar syrup, dishwash, water, and edible. Here is the densities of each one, and that's why they seem of different colors. Specific weight and relative density, they are derived from density. Here we can see the formula, that is weight over volume and the density of the solid over the density of the water. Pressure. Here, as you can see, is the formula of pressure, that is force over area. Pressure is defined as the force per unit of area, and it is a scalar quantity. The units used in the international system are pascals or newtons over meter square. An example of pressure is the bed of nails. If you stand up on it, it will bore into you. But if you lay all your body, it will not hurt you because you're applying the force in a bigger area, so pressure will decrease. Here we can see the example. This is the bed of nails. This is a balloon, and this is the area distributed between the nails and the balloon. And this is external force, so as you can see, it doesn't pop. Pressure is important because it's needed when a piston leaves a car, when pressing the buttons of your tablet or cell phone. In pipes, a certain pressure is applied so water can go through them, etc. Pressure and fluids. First of all, we're going to state something. Fluids exert pressure in all directions, and is the same pressure in all directions. To obtain the pressure, we use the formula density times gravity times height, or often called hydrostatic pressure. So there is pressure that is directly proportional to the density and the depth of a liquid. When a container is open to the atmosphere, like here we can see the glass, the pressure of it is acting on the surface of the liquid. Therefore, the total pressure will be the pressure of the atmospheric pressure plus the density times the gravity times the height, is hydrostatic pressure. Pascal's principle. The principle is obtained when applying the equation of pressure in the interior of a liquid. It states that the change in pressure in any point of the enclosed fluid at rest is transmitted to all points of the fluid and acts in all directions. This is the piston, and this is how lift the car. Pascal's principle is important to have lifting cars and the function of hydraulic systems in the cars.
Today I am going to talk about heat. Well, the first topic is thermal equilibrium. Well, imagine you have this system in which too many components are together. For example, ice, we have this cube ice, and maybe water at room temperature, oxygen. So we have two components in one system. Well, let's suppose that you pour your ice cubes into a glass of water. What will happen? Well, water is at 20 Celsius degrees, and ice cubes is at 0 Celsius degrees. Thermal equilibrium has as a variable the temperature. These are temperatures, and that means that the variables are these. Let's suppose that it's raining and it's cold, and we have here a water drop. Well, here we have a lot of when the wind hits the drop. Okay. So we have three states of matter that are solid state, liquid state, and gaseous state. What happens when the wind hits the drop? Well, the drop is going to transform into a hailstone, passing from liquid state to solid state. And obviously, the molecules are going to compress.
Okay, in the stage 3, we're going to see the topic electricity and magnetism. Okay, so in the first part, we have the generation. And here's an example of a simple electric generator which is made by magnets and by coiled copper wire in the form of a cylinder. And this cylinder, it spins and it creates between the magnets and the coiled copper wire a space of electromagnetic energy with small amounts of electric energy at the time, and it goes in the form of a current to the consumer. And here is the electricity coming out. Moving on to the sources, we have 5 main sources of electric energy. And the first one is chemical. This one is made up when you burn carbon-based materials, for example, wood. And it produces heat energy, which is then transformed into electric energy, for example, in a battery. Then we have the thermal energy, which comes from things that are underneath the earth. Like, for example, when you burn fossil fuels, also combustion, or natural gas. Then the kinetic energy comes from movement, and it is when the turbines of an eolic plant or an hydraulic plant spin with the force of the air or the water, and with that movement it creates the electric energy in an electric generator. And then the nuclear energy, it comes when you split an uranium atom, and this creates heat in the form of steam, and then this goes into also a generator like this one, and it creates the electric energy. And the solar energy comes from the solar panels, which transform the solar energy directly into current that goes to the consumer, obviously. Okay, so moving on to the next topic, the magnetic field in the electric lines or power lines. Most of you know power lines. They are made by towers and by wires that connect the towers, and these help to transport the electricity for long distances. So what do magnetic fields have to do with these towers? Well, basically, all of this system creates a magnetic field, an invisible force, an invisible energy. So it emits radiation, but in a low frequency, so it is not harmful for humanity. And the last topic is the domestic electric circuit. And this is a circuit that is composed by 3 main wires. The first one, that is green, is the earth wire, and it is a safety measure that they built in the circuit. And then there are the red and the black wires, and these 2 wires are the ones that connect through here, and the electric energy that is transferred from here goes into here and these cables to all the circuit until it reaches the house. Thank you.
Hi, good afternoon. My name is Marta Sanchez, and I'm going to talk about the sound. Okay, the sound is a mechanical and longitudinal wave. This means that it's a medium to propagate. And I'm going to talk about 4 principal things: sources of sound, speed of sound, the sound transmission, and the sound intensity. I'm going to begin with sources of sound. I have 3 principal sources of sound: vibrating solids, rapid expansions or compressions, seismic explosions or implosions, and smooth air flow around building obstacles may result in the formation of vortices. And this is when we whistle or when we play the flute. And I'm going to follow with the speed of the sound. And the speed of the sound, we can see here that is different in liquid, in gases, and in solids. It depends on the medium and it depends on the state. We can see here that in liquids it's faster than in gases, but is slower than in solids. This is for the movement of the particles, like we can see here. In a sunny day, is faster the movement or the speed of the sound than in a cloudy day. We put, for example, 35 degrees and 15 degrees is faster in a 35 degrees day. And we continue with the sound transmission. It's a passage of sound waves through a medium or a series of medium. And the sound intensity. The sound intensity is defined as the sound power per unit of area, and it's exactly the same as if we say watts over meter square or watts over centimeter square. And we use the decibel scale here. And the most common use of this is for the air in a certain space where people is, and we use the decibel scale. Thank you.
Okay, let's start with optics. The first observations about light were always as the humans. Light was interpreted like the opposite of dark, and the first ideas about light were postulated by Democritus, who believed that the light was an amount of particles expelled by the bodies. Let's talk about the speed of light. Albert A. Michelson obtained with the Foucault method that the speed of light was 2.997 times 10 to the 8 meters per second. Nowadays it is accepted. Okay, the electromagnetic field. The electromagnetic field are a lot of types of radiations that exist. All of them are waves that have an electromagnetic field. Isaac Newton was the first to pass light by a hole that he made in a window, and he directed it to a small triangular glass. And then there appear a lot of band of colors. This spectrum is only a small region of all the electromagnetic spectrum. Let's talk about the reflection of light. A beam of light that is incident on a surface is called incident, and the reject light is called reflected. Okay, now let's talk about the reflection law. A beam of light that incident on a surface with an angle is reflected with that equal angle. That is called the reflection law. Mirrors. There are two types of mirrors. The plane mirrors are the one that reflects light, and the spherical mirrors are the one that has a concave part and a curvature. Lenses. The lenses can be built with crystalline glass or transparent plastic, and they reflect light by altering the waves when they pass in one medium to another. There are a lot of types of rays. The first type of ray is the parallel ray to the axis. Then is the ray that passes through a focal point, and the last one is the ray that passes through a geometric center. In conclusion, this topic is very important because it can be used in a lot of types of works, like when you are trying to break something by using the light or a laser. Therefore, you need to understand the refract light and the angle of light and the reflection law. So it can be used in a lot of things.
So, to review, knowing about physics helps a lot of the people in the daily life. For example, about fluids, it led us to construct distribution webs of water and gas so that our houses can receive that resources. Another example is heat. Knowing about heat led us to construct houses that can preserve heat when it is winter, or to expose heat when it is summer. Also, it is used heat to construct refrigerators, microwaves, and other machines that are used in daily life. Next, we have electricity magnetism, that is used to provide the service of electricity that we are using right now. Finally, we have waves and sounds, that is used to explain the phenomena that occur in our daily life.